Percentages. Most of you who are good in percentages, start listening to the class. You will understand the whys of a few values. Percentage to fraction. Percentage to fraction. Now, when you are converting it into a fraction, which is nothing but a rational number, which is nothing but a rational number. A rational number is a number which is of the form P by Q. P and Q are integers, Q not equivalent to 0. Next one, right? Percentage to fraction. Sir, 5 in our institute, some people taught us 1 by 7 is 14.2857, that is getting repeated, right? Which all fractions? Fraction is nothing but a rational number, right? If P and Q, if the numerator is a factor of the denominator, it can be further combined. I discussed about P by Q. P and Q are integers, Q not equivalent to 0, right? P and Q are co-primes, then it will be simplest form. Then we will discuss some problems related to terminating decimal. Listen to every concept, sir. Terminating decimal. And then we will discuss non-terminating decimal. Why few values, right, in our textbooks 1 by 9 is written as 0.111111. Why 2 digits are getting repeating? In non-terminating, we will discuss the concepts related to recurring decimal. Then we will discuss the concepts related to non-recurring decimal. Non-recurring decimal. Then we will solve approximation concept in percentages. Approximation concept in percentages. If two numbers are multiplied, how to do approximation? Should I approximate both the numbers? Should I approximate smaller number? Should I approximate a larger number? If it is in division, how to do approximation concept? If it is in division, how to do approximation concept? Some practice problems. Today's class will be a basic fundamental concept. As you know, I am a great believer of Finland education system, which is the world's best education system. Your idea should be entirely focusing on this value. At the end of the class, what are you going to get? Outcome is, see here, 329 by 637. What you will do in your institute, 10%, 5%, some concept will be given. How to get these answers? Each question, probably if you practice it, you will be able to solve this question in less than 10 seconds. Instead of doing 10%, 1%, 50%. That logic we will discuss. When to use a digital sum, when not to use a digital sum, everything comprehensive coverage. Percentages, as I told you, percentages is one topic where I am going to stress a lot on fundamentals, because if you take DI, data interpretation, if you are good in percentages problems, it will help you to solve. You should be good in either percentages or ratios or speed calculations. Or speed calculation. As most of you know that DI is either calculation intensive DI or it is arithmetic based DI or it is logical reasoning based DI. Once I go through the percentages comprehensive class, then if I take DI problems, you will start falling in love with the way I solved DI problems. Percentages. In case if you are preparing for any examination and listening to the class for the first time, you can go back and see a lot of free videos. You can check it out, and if you think, right, you are learning a lot, probably you can enroll for the course, right? So these are the concepts which we are going to discuss today. Percentages, rational number, approximation. How to do approximation in multiplication? For example, 18.9% into 24.9%. Should I write it as 19% of 24.9, or should I write it as 18.9% of 25%, or should I write it out as 19% of 25. There is a lot of confusion. Today we will clarify each and everything. Now see here, concept by concept, please write down. I will teach, all you have to do is just to listen to the class, write it down in your notebook in the way that I am teaching. Concept 1. Concept 1. First listen. A rational number is nothing but a combination of integers and fraction. A rational number is a combination of integer and fractions. So a rational number is of the form P by Q. P and Q are integers. P and Q are integers. Q not equivalent to 0. Denominator cannot be equivalent to 0, then it gets into an undefined form. P and Q are two integers. If I select two integers, three cases I will get. P equivalent to Q. P is less than Q. P is greater than Q. P is less than Q. Then this fraction is called as proper fraction. Then this fraction is called as proper fraction. If P is equivalent to Q, then it is called as an integer. 4 by 4 is 1. Write 8 by 4. These P is equivalent to Q. Integer value will be 1. If Q is a factor of P, if Q is a factor of P, P by Q value will be greater than 1. Two cases, either it can be equivalent to 1, if it is equivalent to 1, 2 by 2, 3 by 3, 4 by 4 and so on 1, or 4 by 2, or 6 by 3, or 12 by 3. If the denominator is a factor of the numerator, for example 12 by 3, it will result in an integral value greater than 1. P is greater than Q. That means numerator is greater than denominator. If so, we have to convert it into a mixed fraction. From here, definition of mixed fraction will come into picture. Listen carefully, sir. Entire percentages, you are going to convert it into fractions. A fraction is nothing but a subset of rational number. So it is extremely important for us to understand fractions so that we are very comfortable with percentage to fraction and fraction to percentage. P is less than Q, proper fraction. P is greater than Q, improper fraction, mixed fraction. From there, if it is 7 by 3 is there, it is nothing but 2 plus 1 by 3. From there, mixed fraction will come into picture. Now, this is a P and Q are integers. P and Q are integers. Therefore, all our percentage problems, P and Q will be integers. Now, in these concept 1, suppose 1 by 2, it is a rational number. 1 by 2, it is a rational number. 1 by 7, it is a rational number. 13 by 5, it is a rational number. It is an improper fraction. Root 3 by 1, it is an irrational number. An irrational number cannot be represented in the form of P and Q, where P and Q are integers. Root 3. It is not an integer. Now, 1 by 2, 1 by 7, 1 by 3 by 5. If I convert it into 1 by 2, it is nothing but 0.5. 1 by 7, it is nothing but 0.142857 on this bar is there. 1 by 5, if I multiply by 100, this is nothing but 0.20. 0.20, right? If I take 1 by 9, it is nothing but 0.11 bar. For some numbers, I am getting the same some digits, pattern of digits repeated. For some numbers, it is nothing but a terminating decimal. When I take a rational number, sometimes, suppose if I take 2 by some x number, it could also be 0.134578269. Sequence of digits are not repeating. For some rational numbers, the digits are repeating, bar is there. For some rational numbers, after dot, there are finite number of digits. It is infinite number of digits. But the same set of digits are repeating. But here different set of digits are repeating. There are various right hand side values that are possible. Finite number of digits, infinite number of digits, but a sequence of digits getting repeated. Infinite number of digits, but some sequence of digits are not getting repeated. This gives us one more definition. What is the definition? We will write. What is the definition? Suppose if I take a rational number, listen carefully, sir. First class is an extremely important class. Further classes it will be extremely easy for you, because sometimes when I use one concept, if you do not know the fundamentals, you might ask me, sir, why did you use this? Why did you not use this? Today I will discuss all the basic understanding so that your DI will be strong. If I convert it into decimal, there is a terminating decimal and there is a non-terminating decimal. Non-terminating decimal. Terminus, it is nothing but dead end. Terminal, that means finite number of digits. Write down in the same order. You will understand the power of structured learning at the end of the class. Terminating decimal is a decimal which has a finite number of digits. Non-terminating, so there is no end to it. There is no infinite in mathematics. There is only countable infinite, sir. Countable infinite number of digits. Please, with your innocence or ignorance, don't call this value as infinite. It is countable infinite. What is the difference between countable infinite and infinite? In countable infinite, you can count it, but you have better things to do in life. How many numbers are there between 1 and 2? If you sit, you can count it, but you will not waste your time. How many stars are there in a sky? Right? You can count it, but you will do other things in life. How many points are there in a straight line? All these will have a cardinality aleph 0. These I teach for MSc mathematics students, not required. These countably infinite number of digits are in simple right school level. They call it as infinite and countable infinite. Like we say, ratio and fraction both are equal. Ratio and fraction both are equal in terms of value, but in terms of meaning, both are different. Value wise both are same, meaning wise both are different. Ratio means, suppose there are 4 pizzas. There are 4 pizzas. I took 1 pizza out of 4 pizzas. I took 1 pizza out of 4 pizzas. These are nothing but ratio. There are 4 equal size of pizzas. I selected 1 pizza out of 4 pizza. These are nothing but ratio. There is 1 pizza. I divided into 4 parts. 1, 2, 3, 4. I selected 1 part out of 4 parts of the same pizza. Part cancel. It is 1 by 4. Most of the students who does not, even teachers also, who does not have a greater deep 100 feet understanding of ratio and fraction, they both say that both are equal. Value wise both are equal. Part cancel 1 by 4. Pizza cancel 1 by 4. Meaning wise both are different. Meaning wise both are different. Ratio is, I selected 1 pizza out of 4 pizzas. 1 pizza out of 4 pizzas. 1 part out of 4 parts. What is a fraction? Fraction is out of 1 quantity you are taking a piece. If you take a piece out of the total quantity, then you call it as a fractional value. 2 by 3. Out of 3 parts in a pizza, you are taking 2 parts. So semantically that is the meaning. Terminating decimal, it has got finite number of digits. Non-terminating, countably infinite number of digits. When I say it keeps on proceeding, then these non-terminating, most of the students will struggle in DI problems only because of this fundamental Misunderstanding of the concept. Neither the teachers will teach, they will directly go with A percentage equivalent to A by 100. That is an R.S. Agarwal approach that will lead you to nowhere if you are solving high level problems. These terminating decimal. These terminating decimal. These non-terminating decimal. Non-terminating decimal. Non-terminating decimal. This slide is of extreme importance slide, sir. Very, very important slide. Terminating decimal. Terminating decimal means it will result in dot. After dot, dot, there will be finite number of digits. After dot, there will be finite number of digits. Sir, under what cases I will get a terminating decimal? A rational number, if p greater than q, p less than q, it is of the form numerator by denominator. dr is nothing but denominator. dr is nothing but denominator. If the denominator has only powers of 2, if the denominator has only power of 2 or only power of 5 or powers of 2 and 5, then only I will get a terminating decimal. Then only I will get a terminating decimal. Terminating decimal means after decimal, terminus, end point, number of digits will end. Because it is ending after dot, then it will have finite number of digits. That means under what case it will have terminating decimal? Only when the denominator is either powers of 2 or powers of 5 or powers of 2 and 5. Sir, why it should be powers of 2 and 5? Because when you are converting a fraction into percentage or a decimal, you are multiplying by 100. The prime factors of 100 are 2 and 5. Prime factors of 100 are 2 and 5. The simplest form of a rational number is numerator and denominator should be co-prime to each other. Please write down. Numerator and denominator, they both should be co-prime to each other to be in its simplest form. To be in its simplest form. 4 by 6 is not in its simplest form. When I say a rational number, I am only discussing the case where it is converted into an simplest form. A fraction is said to be a simplest form when the numerator and denominator are co-prime to each other. What do you mean by co-prime? Mathematically, HCF of a comma b equivalent to 1. For example, now comes the beautiful idea. 3 by 8. 3 and 8 are co-prime to each other. They have only one factor common. 8 is nothing but power of 2. So this will result in percentage or in decimal. It will result in terminating decimal. Suppose if it is 5 by 16, 16, it is 2 power 4. It will result in terminating decimal. I hope you are all there with me. 7 by 200. 200 is nothing but 7 by 2 into 2 cube into 5 square. 8 into 25. If the denominator has only powers of 2 and 5, then only I will get a terminating decimal. If the denominator has only powers of 2 and 5, then I will get a terminating decimal. Then I will get a terminating decimal. Anything other than 2 and 5, it will result in non-terminating decimal. If you understand this one, in DI lot of calculation based problems, you can solve it orally. Which of the following are terminating? Which of the following are terminating or a non-terminating decimal? Still we have not discussed repeating decimal and not repeating decimal. Suppose for example 13 by 32, 17 by 21, 53 by 125, 97 by 80, 16 by 80. First thing, numerator and denominator should be co-prime to each other. Make it into co-prime to each other. HCF of numerator and denominator should be 1. Then only the equation fraction is said to be in its simplest form. Even equation also is said to be in its simplest form if the coefficient of variables are co-prime to each other. 32 is 2 power 5. It is a terminating decimal. It is a terminating decimal. 17 by 21. 21 is 3. Non-terminating decimal. Non-terminating decimal. 125. 5 cube. It is a terminating decimal. It is a terminating decimal. 80. 2 power 4 into 5. 6, 2 and 5. It is a terminating decimal. It is a terminating decimal. 80, it is not in its simplest form. Make it into simplest form. 1 by 5, 5 power 1. It is nothing but a terminating decimal. It is nothing but a terminating decimal. I hope the idea it is clear. It can be nothing but a terminating decimal. Idea is clear. One more example. I will write it. 17 by or 7 by 16. It is 2 power 4. 2 power 4. It is a terminating decimal. It is a terminating decimal. It is a terminating decimal. I hope it is clear, right? So, which of the following are terminating or a non-terminating decimal? This is a non-terminating decimal. Why am I discussing this? Now see here. Why am I discussing this? Denominator can be power of 2 or power of 5 or power of 2 and 5. Power of 2, power of 5, power of 2 and 5. Then only it will result in terminating decimal. It will result in terminating decimal. Then only you can use a digital sum approach. Digital sum approach is used only for terminating decimals. Digital sum approach is used only for terminating decimals. Non-terminating decimals, it will be keep on recurring. Terminating decimals, it is for finite number of digits. Finite number of digits. Why digital sum cannot be used for non-terminating decimal? Let us see. Why digital sum cannot be used for non-terminating decimal? What do you mean by non-terminating decimal? It is nothing but, in simple language, it is nothing but infinite number of digits. Infinite number of digits. For example, if I take 0.125, you can easily say that digital sum is 1 plus 2 plus 5 plus 0. It is 8. If it is a non-terminating decimal, this is nothing but 125 bar. It is nothing but, if I write twice, 8 plus 8, 16, 1 plus 6, 7. If I write thrice, 8 plus 8 plus 8, 24, 2 plus 4, 6. If I am writing bar, I am ignoring all these digits. If I am ignoring the digits, digital sum will get affected. Or it could be 1, 2, 3, 7, 8, 9, 5, 4, 6, 5, 6, 4 and so on. And so on, the digits could be anything. So if the digit value is not there, digital sum will be affected. Keep this in mind. I am going to use this concept in simple interest, compound interest, no formula based approach, in profit, loss and discount, in averages, mixture and allegation, in time, speed and distance and time and work. I will solve arithmetic through a prism that you have never seen probably in your lifetime other than you are an Anil Nair student. Terminating decimal. There are close to about 6 to 7 full-length videos on compound interest in our YouTube channel. None of the video you will find a single formula. Right? Everything is through a logical approach. Terminating decimal. Digital sum approach. Non-terminating decimal. Digital sum cannot be used. Keep this in mind. It helps me to save some calculations. I hope it is clear. When the digital sum is used, when the digital sum is not used. Terminating decimal means denominator should be either a power of 2 or a power of 5 or power of 2 and 5. Now comes the most important part. If the denominator, it is, if the numerator and denominator, if the denominator is not equivalent to, if it is not equivalent to power of 2, power of 5 and power of 2 and 5, then it will result in non-terminating decimal. Then it will result in non-terminating decimal. In non-terminating decimal, there are two ways. One is recurring decimal. One is recurring decimal. A few set of digits, sequence of digits gets repeated. Sequence of digits gets repeated. If the sequence of digits gets repeated, recursion is repetition, right? Non-recurring. There is no sequence of digits which will get repeated, right? There is no sequence of digits that will keep happening, but there is no particular pattern of digits that will get repeated. Now comes the next point. Sequence of digits repeated. If the sequence of digits is repeated, suppose for example 2 by 7, it is nothing but a recurring decimal. Then the question comes, how many digits it will be repeated? 5 by 13, how many digits it will be repeated? 7 by 29, how many digits it should be repeated? I hope the idea it is clear. We are finding the cyclicity of the sequence of digits which are repeated. We are finding the cyclicity of the sequence of digits which are repeated. Idea it is clear, right? So if it is a terminating decimal, multiply by 100, natural after some digits you will get it, and that is also easy. If it is 1 by 2, it will be 0.5. 2 power 1 after dot 1 digit, okay, that I will tell it in the other way. 1 by 2 power 1, 1 by 2 it is 0.5. 2 power 1 after dot 1 digit it is finite. 1 by 2 square it is 0.25. 2 digits after dot finite. I hope the idea it is clear. How to find out the finite number of digits? 1 by 5 power 1, 0.2 after dot 1 digit. 1 by 5 square, it is nothing but 1 by 25, which is 1.04, 2 digits. 1 by 2 into 5, this 1 by 10. 1 by 10 is, right, it is 10 percentage, 0.1, 1 and 1. I hope it is clear. Suppose if it is 1 by 2 cube into 5, 1 by 40, 1 by 40, 1 by 40 in percentage, then I will put 2 digits. These is nothing but 2.5. These is nothing but 0.025. 0.025. I hope the idea it is clear. 0.025. Now if it is there, 2 power, how much it is there? 3. 5 power, how much it is there? 1. Take the LCM of 3, 1 to find out how many finite digits are there after dot. Suppose if the question is 1 by 2 power 8 into 5 power 4, after dot, how many finite digits it will be there? How many finite digits it will be there? How many finite digits? LCM of 4, 8, which is nothing but 8. I hope the idea it is clear. These to determine the finite number of digits. These is nothing but to determine the finite number of digits. This can be written as 1 by 2 power 4 into 1 by 2 power 4 into 1 by 5 power 4. 2 power 4 into 5 power 4, 10 power 4. After dot 4 will come. 1 by 2 power 4, 1 by 2 power 4, again after dot 4 will come. I hope the idea it is clear. 0.1 into 0.1 it is nothing but 0.01. So here after dot 4 will come, after dot 4 will come. So it will be 8 digits. That is nothing but the LCM of 4, 8. Whatever I am teaching you in your NCERT textbook, these all should be taught in your school days for you to understand the beauty of percentages. We are too much enamored with percentage le lo, fraction magap kar lo, problems. No, it is not like that. If you are studying like that, you are moving in the wrong direction. You are being taught by a teacher probably which does not come. It is like a coach and a player should have a great understanding. It is extremely important to have a great coach, right? Arjuna was an extremely great warrior, but it required a mentor called Krishna not to teach 1 chapter, 2 chapters, 3 chapters, but 18 chapters to tell Arjuna, understand the difference between easy and right. Understand the difference between chasing passions and bringing emotions, right? So it's extremely important for you to understand these. What do you mean by terminating? What is recurring? Once your fundamentals are strong, then everything will go place. Finite we discussed. Then we are discussing non-terminating. In non-terminating, our focus is on recurring decimal. Another important slide, sir. A recurring decimal, numerator by denominator. Now see here, numerator by denominator, recurring decimal. Denominator cannot take power of 2 or power of 5, or it cannot take power of 2 and 5. That means it can take any other value, any other prime number. Let us take, because every composite number can be written as a power of prime number. Are you all with me? Every composite number can be written as a power of prime number. 21, it is nothing but 3 into 7. 16, it is nothing but 2 power 4. 30, it is nothing but 2 into 3 into 5. Are you all with me? It can be, denominator can be a prime number other than 2 and 5, or it can be a composite number which can be written as a power of prime number. Next slide, listen carefully, sir. Carefully. Right? None of the concepts, whatever I am teaching, right? You open any Indian textbook, whatever I am teaching, you will not find it, right? Of course, other than Hungarian book of mathematics, which is the world's best book on mathematics. Denominator. If it is a prime number, that means it can be 3, it can be 7, it can be 11, it can be 13, it can be 31, and so on. So if the denominator is a prime number, let me call it as P, then the cyclicity after dot will be P minus 1. Cyclicity after dot will be P minus 1. These based on Fermat's little theorem. A power P minus 1 divided by P, it is 1. Rational number, numerator and denominator should be co-prime, and the denominator, it is a prime number. That means if it is 3 by 7, what is the cyclicity? Point. How many digits will be there after dot? 7 minus 1. 6 digits will be there after dot. That means answer for this question will be 6 digits. A, B, C, D, E, F slash. Suppose if it is these maximum number of digits, sir. It can be the factor of P minus 1 also. Maximum number of digits. Maximum cyclicity, it is 4. How now? If it is 7 by 13, it is point. After dot, after how many digits? Definitely it will be repeated. 12 digits it will be repeated. Cyclicity, that means the number of digits maximum number of digits after which cyclicity number of digits will be repeated, it will be 12. Now listen carefully, sir. Suppose if I take the unit digit of a number, if I take the unit digit of a number 2, then it is 8, 2, 8 and 3. Unit digit will get repeated after 4 steps. You know it very well. 5 and 6. Unit digit will get repeated after 1 step because 5 power 1 is 5. 6 square is 36. After 1 step, then it is 4 and 9. It is nothing but 2. Why? Because 4 square it is 16 and 4 power 4 is 256. Again the unit digit is 6. What is the generic cyclicity? Generic cyclicity is the LCM of 1 to 4. LCM of 1 to 4, it is nothing but 4. That means after 4 powers, definitely unit digits will be repeated. After 4 powers, unit digit will be repeated. Unit digit will be repeated. I hope the idea it is clear. Similarly, if I take 5 by 11, it is point after dot. What is the maximum number of digits the repetition will be there? P minus 1. 10 digits it will be repeated. It is not only 10, it can also be a factor of 10. What are the factors of 10? 2, 5 and 10. 1, 2, 5 and 10. It can repeat after 2 digits. It can repeat after 5 digits. It can repeat after 10 digits. Generic cyclicity, it is nothing but 10. I hope the idea it is clear.